Example 1, identify the intervals for which the function is positive, negative, increasing, and decreasing. So let's start with identifying the positive interval in part A. So when we say positive, we're referring to the function being positive. In other words, the y value is being positive. And that means this portion of the parabola, which is above the x-axis. So it starts here at an x-coordinate of 0 and ends here at an x-coordinate of 6. And essentially, all we have to do is state the domain for this part. So if we scan to the right, we know that it doesn't go past 6. And if we scan to the left, it doesn't go past 0. So I can write that for the positive interval, x belongs to the real number set such that x has to be greater than 0 but less than 6. And notice that I'm not writing equal to 0 or equal to 6, because when x is equal to 0 or x is equal to 6, the y-coordinate will be 0. That's neither a positive number or a negative number, so we have to leave out the equal signs. Now let's look at the negative intervals. There are two parts on the parabola where the y values of the function is negative, here and here. So we have to consider them both. So if I look at this part here on the left, I notice that if I scan to the right, to the left, it's going to continue growing. If I scan to the right, it doesn't go past 0. Okay, so I can start by writing that the negative interval would be x belongs to the real number set such that my x value has to be less than 0. Okay, because it goes up to 0 here. And again, it doesn't include 0 because then the y value would be 0. And we need it to be negative. And we also have to consider this part here, so we're going to write the word and. And for this part, if I scan to the right, it's going to continue growing, but to the left, we know that it ends here at an x-coordinate of 6. The rest of the x-coordinates will be greater than 6. So we will write x has to be greater than 6. If you compare the positive and negative intervals, notice that just the signs are reversed here. Here we have x being greater than 0, but here we have less than 0. Here x is less than 6, here x is greater than 6. So if you can correctly determine the positive interval, you can get the negative interval by simply reversing the signs. Okay, let's look at intervals of increase and decrease. So the axis of symmetry divides our parabola into an increasing side and a decreasing side. The way that you can figure out which side is increasing or decreasing is just by following the parabola from left to right. So if I'm redrawing this parabola from left to right, on this side, I'm going up because the y values are increasing. Okay, they're increasing. They start off negative and eventually become positive. So this is my increasing side. That means the other side would be the decreasing side. And I can verify just by following along from left to right. I start with high y values and then they become smaller and smaller and decrease. Okay, so this is my increasing side and it only goes up to this point here, which has an x-coordinate of 3. So the highest x-coordinate we can have on the increasing side here, but not including, is 3. Okay, the rest of them will be less than 3. So I'm going to write the increasing interval is x belongs to real number set such that x has to be less than 3. Okay, now the decreasing side, okay, as we're scanning to the right, it goes all the way to the right, but to the left, we stop at an x-coordinate of 3. So for the decreasing interval, I'm going to write x belongs to the real number set such that all the x-coordinates have to be greater than 3. Like so. Okay, again, we don't use the equal sign here because at this point, the parabola is neither increasing or decreasing. And let's look at the next example here. We're going to do the same thing. First, we're going to consider the positive interval. So it's going to be positive for these two sections here. Okay. So for this section, if I scan to the right, it's going to stop at this value here of -2. So I have to start by writing the positive interval is x belongs to the real number set, such that all my x coordinates are going to be less than -2. But I also have to consider this part, so I write the word and for this part, scanning to the right is going to continue to grow, but scanning to the left doesn't go past this point where the x coordinate is 5. And the rest of the x coordinates have to be greater than 5 here. Now for negative, this is the portion of that parabola I consider. The lowest value here goes up to -2 and the highest up to 5. And then there's going to be all these x values in between. So the signs will just be reversed. So this time x has to be greater than -2 but less than 5. And if you prefer, you can also write it, the alternative is to write it in two parts like we did for the positive section and just reverse the signs if you prefer. Okay, you can do one or the other. Okay, now for positive and negative, again, we're going to use the axis of symmetry. Which has the equation x equals 1 here. And this time, the increasing side is going to be this side here. This is the right side. Because if I go from left to right, my y values would be increasing here. And if I go from left to right, they would be decreasing here. So if I focus just on this section here, my increasing section, all the way to the right is going to continue growing, but it won't go past this point where the x coordinate is 1. So the domain for that part is going to be x belongs to the real number set such that x has to be greater than 1. And for the decreasing side, really I just need to switch the signs because it'll be on the other side where x is equal to 1. Okay, now a couple things you should notice to make it a little bit easier to remember how to state the intervals. If you're asked to state the intervals for which the function is positive or negative, you're focusing on the zeros here, the zeros, -2 and 5, for example, you see here, -2 and 5. And if you're focusing on intervals of increase or decrease, you're focusing on the axis of symmetry or the x coordinate of the vertex, which in this particular case is 1.